Welcome back on units. From the inception of this topic, it is measurement and units. After measurement, we jump to units. Now we are on units. What is unit? From what we have been told before, unit comprises of two things. Number one is fundamental quantities and units. Number two is derived quantities and their units. So, we shall start from number one, which is fundamentals, the fundamental quantities and their units. So number one is fundamental quantities and units. So if I might ask, what is fundamental quantities? They are the basics of quantities. They are quantities that are dependent on themselves, that are independent on other quantities. They are basics for quantities. Do you get? So these fundamental quantities are not derived from any other quantities. They are themselves. They are quantities like time, length, mass, temperature. So there are many quantities. After we shall list all the quantities for you. The same goes with units. What is unit? Units are those units. What goes with fundamental units? Fundamental units are those units that are dependent on themselves. They are not independent on other units. They are the basics of units. And again, in these fundamental quantities and units, there are three basics measurements. There are three basics fundamental quantities, which is length, time, and mass. This is the basics of all fundamental quantities and units. So, let's discuss about all the fundamental quantities, their abbreviations, and their units. Okay, let's just draw a tabular representation of all these things. Welcome to the tabular representation of these fundamental quantities and units. This is quantities. This column here is for unit. This is the abbreviation. So, from the first one, the time is a quantity. The first quantity is time, which is measured in seconds. And the abbreviation is just single s. The second is mass, which is measured in kilogram, and kg is the abbreviation. Length, measured in meter, m is the abbreviation. Electric current, which is ampere, it is measured in ampere. Capital A is the abbreviation. Temperature, Kelvin, capital K. Luminous intensity, candela, Ca. Then magnetic flux, Weber, which is measured in Weber. And this is symbol for its representation. Now, we have done some little work on fundamental quantities. Let's now jump into derived quantities. Derived quantities are those quantities that are gotten from fundamental quantities. They are not dependent on themselves. They depend on the fundamental quantities. Without fundamental quantities, there is nothing like derived quantities. They are gotten from the fundamentals. So, let's leave some tabular representation of all the derived quantities that are gotten from fundamental quantities. Although these derived quantities can be two fundamental quantities, 3 or 4, like from 2 to infinity, as many as they are combined to be a derived quantity. Let's give you some tabular representation of derived quantities and how to get their units and their abbreviation. Okay? So, welcome to derived quantities. The tabulation. This column here is for quantities. Here is for derivation. Here is for derivation. Here is the derived units. So let's demarcate all these tables. The first one is area. Area, which is just length times breadth. Area is length times what? Breadth. Length, how can we determine the unit? The unit of length is meter. The unit of breadth is also meter. So here is meter times meter, which will give us meter squared. The same goes with volume. Volume is length times breadth times height. Length times breadth times height. Length, the unit is in meter. Breadth is measured in meter. Height is measured in meter. So the unit goes like this: meter times meter times meter, which will give us meter cube. Speed, which is distance over time. Distance over time. Distance is measured in meter. Time is measured in seconds, which is meter all over what? Second. This thing also means meters times s seconds raised to power minus 1. Once this seconds is coming from the denominator, it adapts a negative 1. It will be raised to minus 1. This also means that it's at the denominator, because s raised to minus 1 is over s. So when you remove this thing is the same thing as m over 1 times this, which is m over s. So this is meter times second raised to power minus 1, which is meter per second. Okay, and also if you're having issues with this, just try and visit our indices in the mathematical section. Okay, the next is velocity. Velocity, which is displacement over time, and displacement is also measured in meters. Time is measured in seconds. It has the same thing with speed. It has the same unit with speed. Meter over time, which is meter per second. The next is linear acceleration, which is velocity over time. Linear acceleration, which is velocity over time. Velocity, as we know, is meter per second. Time is second. So this is meter per second all over second. So when this second comes up, it will take minus 1, and this will give us m minus 2. That is meter per second square. The next is force, which is mass times acceleration. Abi? Yeah. Mass is measured in kg. Mass is measured in kg times acceleration is measured in meter per second square. Meter per second square is for acceleration, which is this. Mass is measured in kg, which will give us kg meter per second squared. The next is density, which is mass over volume. Density is mass over volume, which will give us kg over meter cube, which will give us kg per meter cube. That is density. For energy of work, they have the same derivation and units with moment, which is force times distance. This is force times distance. Force, as we already know, force is kg, kilogram meter per second squared, which is kilogram meter per second squared times, this is force times distance, which is measured in meters. It will give us kg m squared s minus 2, kilogram meter squared per second square. The next is pressure, which is force over area. Pressure, force over area. Force is also kg meter per second. Abi? Force, if you check from our force, it is what? Kilogram meter per second squared divided by area, which is meter squared. It will give us kg meter minus 1 per second. That is kilogram per meter per second squared. The next is impulse, which is force times distance. Impulse, which is force times time. Impulse is force times time. Force again is measured in kilogram meter per second squared times second. So this will give us kilogram meter second. Okay, this is where we stop for derived quantities. Then jump into dimension and know how to determine the dimensions of any quantities that we are being asked to determine. Thank you. Dimension of physical quantities. When we talk about dimension of physical quantities, what does it mean? We are trying to relate how these physical quantities is being related to their fundamental quantities. That's what dimension means. We are trying to connect them, the relationship between these physical quantities and their fundamental quantities. And also, when any physical quantity is measured in terms of length, when a physical quantity is measured in terms of length, it is said to have a dimension of L, capital L. When a physical quantity also is measured in terms of mass, it is said to have a dimension of capital M. That is in terms of mass, have a dimension of capital M. And when a physical quantity is measured in terms of time, it is said to have a dimension of capital T. That's how dimension goes. And again, I normally like to clear this confusion that students normally do. They usually misplace dimension with units. When you ask them to get the dimension of anything, they go ahead getting the unit for you. Let's say let me just use this length for example. The dimension of length is L, and the unit of length is just meters. That's the difference. Dimension is just a way in which they are being connected with their what? The fundamental quantities. And unit is just a means of measuring them. That is the unit. The unit of length is meters. And the dimension for length is what? L. The unit of mass is K. The dimension of mass is M. The unit of time is seconds, but the dimension of time is capital C. And again, whenever you are dealing with dimension, always put them in a bracket. We normally enclose them in a bracket. Anytime you are talking about dimension, you put it in a bracket like this. This is very necessary. So let's just start and generate the dimension of some physical quantities that we know. Let's start with volume. Let's say volume. The dimension of volume is being gotten. This volume is a derived unit. So the dimension of volume is the formula for volume first is length times breadth times height. This is the formula for volume. So from this formula, let's derive their dimension. This L is length. It is measured in terms of L. It's measured in terms of L and dimension of length, L, capital L. Breadth is also measured in terms of length and has a dimension of capital L. Height is measured also in terms of length and has a dimension of L. So the dimension for volume is just capital L Q. The same thing is applicable for area, which is length times breadth. L, which is length, has a dimension of L. Breadth, which is length, has a dimension of L. Therefore, dimension for area is L squared. We enclose in a bracket. We enclose in a bracket. That's it. So let's check the dimension for velocity. Let's start with speed first. Speed, the dimension for speed, which is, this speed is a derived unit. The dimension for speed is distance over time. That is distance over time. Distance is measured in terms of length. It is measured in terms of length. And anything measured in terms of length has a dimension of L. Time is measured in terms of time and has a dimension of capital T. So let's enclose our bracket. Enclose our bracket. So this equally means length times 1 over C. Let me just break this thing down for beginners. And anytime you see 1 over anything, 1 over anything means the inverse of that number or that letter. And the inverse of anything in indices form means T raised to the power minus 1. Therefore, the dimension for speed now from here, the dimension for speed now from here will be what? LT minus 1. We are enclosing our brackets. This is the dimension for speed. How about velocity? Velocity and speed have the same dimension because velocity is displacement over time. Displacement all over time. And displacement is measured in terms of length, which has a dimension of L. Time is measured in terms of time, which has a dimension of capital T. And it equally gives us the same thing with speed. How about linear acceleration? How about acceleration? Acceleration. Acceleration is just velocity all over time. From our previous solved example, velocity is LT minus 1. LT minus 1. All over, our time is time. So, using this same example, or if you find this thing very difficult to comprehend, just visit our mathematical section, indices. It is well explained for you. Then therefore, dimension for acceleration is LT minus 2. That's our dimension for acceleration. You can equally find the dimension force, which says that force is mass times acceleration. Mass times acceleration. Mass is measured in terms of m. Mass is m, capital M, with enclosing our brackets, times our acceleration. From here, acceleration is just LT minus 2, which will give us a dimension of mass LT minus 2. This is it for force. So dimension plays a very important role again. It can be used to verify or check formulas. Using dimension analysis, prove that V is equal to UAT. As we know, dimension analysis, this dimension is a way of verifying formulas. So from here, V is our final velocity. And velocity has a dimension of LT minus 1. This is the dimension for velocity. This U is our initial velocity. Our initial velocity has a dimension of the same thing with our final velocity. Acceleration, this A, has a dimension of LT minus 2. And our time, which has a dimension of what? Capital T. All you got to do now is just substitute all these inside your formula and check the validity of this formula. You check the accuracy of your formula. So this V here, our V is equal to this. So let's substitute. LT minus 1 is equal to U, which is LT minus 1, plus A, which is LT minus 2, and our time. Let's enclose in our brackets. Let's enclose times our normal time. So if we check now, this is LT minus 1, LT minus 1, then we multiply this out. Let's put our bracket, LT minus 1 is equal to LT minus 1 plus we use law of indices. LT minus 2 times T. We first of all pick our L and drop. T minus 2 times T. We pick 1 T according to law of indices. We pick 1 T, we add their powers, which is minus 2 plus 1. And minus 2 plus 1, if you just carry out the calculation, it means negative 1. So let's just substitute straight. This will give us negative 1. And if you check this formula now, you see that anything in the left-hand side is equal to the individual make-ups of the right-hand side. This is LT minus 1. It is equal to this and also equal to this. And the two of these is equal to themselves. This is how to prove any formula using dimension. Okay, this is the end of our topic. So, don't forget to follow your exercises. Believe me, that exercises will help you a lot in this topic. Was to comprehend everything we just did and understand everything you're going to learn from that exercises. You are covered for this topic. There's no question under unit and measurement that you find difficult to solve by yourself. And again, don't forget, for those preparing for WAEC or JAMB, NICO, all these examinations, we have a link below, link for JAMB and link for WAEC. Just go there, feel free, and see how this examiners is setting questions for you. Just go there and learn about your past questions. And again, if you like everything you've seen in this free video, feel free to subscribe, like the channel, and put on your notification for your current videos. And again, you might know a friend of yours that is finding this topic difficult. All you got to do for a friend is just do share with your loved ones, watch with your loved ones. They say a friend in need is a friend in need. Let's share and help others.